This chapter begins with the data description and analysis of natural gas dataset. The research approach as well as the research technique for natural gas consumption by the residential sector will be covered in this chapter. Therefore, Microsoft Excel and Orange software will be used to complete the task. The dataset used in the study for our natural gas usage contain 11 components based on demographic characteristics. We will only use 7 of the 11 factors to build the model. The variable linked with each dataset description are listed in the table. For the analysis and result, we will analyze and comprehend the workflow and model that we created using the Orange program in this session. So, this is our workflow screenshot. Data description and exploration. When we enter the dataset into the Orange software, we first verify the role of each variable that Orange has set for us. Then, we also choose the variable consumption for our target variable. Other variables that do affect the consumption will be set the rule as future, while other irrelevant variable will set the rule as skip. The table shows the variable of the natural gas dataset with their role and types.
Assalamualaikum warahmatullahi wabarakatuh, and I'm Syifa Aini, and I will explain about decision tree. Decision tree can be used in decision analysis to visual and explicitly describe decision and decision making. We can simply conduct a decision tree model using the widget tree in the Orange software. We are doing too much calculating and sketching. In this slide, we can see our data table. After we have the data in Excel, we put the data in Orange software, and we can have this data table. And as we can see, we have like consumption, price, O price, A price, I price, and heating and income and others. So from here, we can see our data table. In this section, we use tree viewer using Orange. Following that, we will able to observe our decision tree model by connecting the tree viewer and tree. To see the current output, click on the tree viewer widget. The result is depicted in the picture below. We can see how the variables are taken and assigned to the next leaf node. The number of depth from this decision tree model is 9, so the tree has split until 9 times. So in here, we can use the prediction to view the assessment result from the database. Go to the evaluate table and pick the prediction widget in the image below. In this section, the conclusion that can be obtained from the result of the description and discussion can be seen below. We can see based on the picture and then the node rules. If heating less than 50.62 equals to yes, then O price less than 973.0 equals to yes. We can see the node rules in here. And then after that, below this is the evaluation result of our decision tree model, which consists of MSA, RMSA, MAE, and R-square.
By using neural network model, we limit our discussion to the most popular structure in supervised classification by examining the multi-layer perceptron (MLP). MLP is a feed-forward network composed of an input layer, hidden layers, and output layer. Then, we use the experimental process to help us to achieve desired result with different neuron in hidden layer and 4 types of activation function, which is first, identify, second, logistic, 3 times, 4 ReLU.
Assalamualaikum, and then we use the test and score with 5 folds for each of the neural network model, and it result that neural network model with activation function of ReLU and neuron in hidden layer 1110 are the best model among the 4 based on the value of MSE, RMSE, MAE, also R-square. Okay, then we test and score with 20 folds, and it result that activation neural network model with activation function of ReLU and neuron in hidden layer 1110 the best model. So from both 20 test and score with 5 folds and 20 folds, we can conclude that among these 4 neural network activation function, you can say that activation with ReLU is the best and more accurate.
Linear regression analysis is used to predict the value of a variable based on the value of another variable. The variable we want to predict is called the dependent variable, while the variable we are using to predict the other variable's value is called independent variable. So the basic equation of linear regression is y equal to a plus bx. A scatter plot diagram is a statistical tool used to show a relationship between two variables. It is often combined with a simple linear regression line used to fit a model between the two variables. The value for MSE, RMSE, MAE, and R square are recorded in the table above. All those are obtained by using 20 folds. The value of R square is minus 325.946 for 20 folds. This result is far away from 1, indicating that the model is not much good and unwell adjusted to the data. After solving using Orange software, we have obtained the equation of linear regression, which is given by y is equal to 217,553 minus 81264.4 p price plus 991,567 e price plus 22.48540 price minus 52581.2 I price minus 14.0472 heating plus 0.160032 income.
We did a comparison of examination of the model, decision tree, neural network, and linear regression using cross-validation to determine which model is the best for solving a dataset of natural gas consumption. We tested the data with different number of folds, 5 and also 20 folds. We compared each of the model using MSE, MAE, RMSE, and R-square value. From the result, we can conclude that decision tree is the best model among the three techniques, since the best performance from decision tree as tested using cross-validation with 20 folds. Decision tree result the smallest value of MSE, RMSE, and MAE. Since they are negative oriented score, then the value that much closer to 0 are more preferable. Also, that the decision tree result the biggest value of R square has higher R square value, as higher R square value correspond to less error on the model.